Today we're looking at Chapter 1, Test Review, and this is for geometry. So we have a diagram here, and throughout this we're going to have pictures, and then we're going to do a few problems on the pictures. So we have a diagram here, and we're going to use this diagram to help us with the next 4 questions. So I'm going to be going back and forth. So the first question, what is another name for line M? A line, when you're naming it, has to have at least 2 points, and they have to be on the same line, obviously. So we're going to look back at line M, which is labeled here. I'll point to it. So line M, you have 3 points on that line. You have U, you have V, and you have T. So that means any 2 points can be combined there to name line M. So you could do just the first 2 points, T, U, something like that. And when you're naming a line, the line symbol has a line over top, the 2 letters with 2 arrows pointing in opposite directions. So that's how you'd label it. Now, 3 points on plane B. We're looking at where plane B is, which is basically the right half of this diagram. Okay, so it's here. Okay, if you see plane B is labeled here. So if we're naming 3 points on plane B, that means that it needs to be any of these 3 points. Basically, the points that are on line M, because those are the main 3 points in the plane. So you would put T, U, and V. And naming points, points have to be named as capital letters. So you would name them as capital T, capital U, and capital V. The next one also relates to the diagram. So this one, name the intersection of planes A and B. The intersection of a plane is always a line, so we're looking for the line between A and B. So this is B, that's in pink. Yellow is A. So the intersection between the two is the middle line here, this line here, which we can indicate as RS. So line RS, and we would put a line symbol on top. Then we're naming 3 non-collinear points. So again, these are points that are not on the same line, and they can be in the same plane. They didn't say non-coplanar, they just said non-collinear. So you could do really any combination of 3 points as long as they're not all 3 on the same line, like for line M. That's about it. Those are the only ones you could not do. So you could do T and then X and then S, really any 3 points that are not on that line. T, X, S, that's good. Now, we have a new diagram here for this one. This one says, what is the length of QR? So you want to do an exact length here. And so that means it looks like R is going right through here, which is actually exactly 1.5. So we would say 1.5 or 1.5 inches. This one I would suggest to draw. So if we draw this out, we have the length of LO. If O is between L and M, so L and M, O is in between. We need to find LO. It gives us LM is 18.6, and it gives us OM is 12.9. So to find LO, the other half, we're just going to subtract the total, 18.6 minus 12.9, which is going to give us 5.7, and that's going to be centimeters. The next one, we're looking at the diagram they've done for us, very similar to the last problem we did, and we're going to find the length of DE. So that means we need to find the value of x first. If we know the total, that means we could put 3x plus 5 plus 5x minus 13 equals the total 24 and solve for x that way. So we combine like terms. We get 8x minus 8 equals 24, and 8x then equals 32 if we add the 8. So then 8x, or x equals 4, but that doesn't have us find the length of DE. We just need to plug that into 3x plus 5, which represents the length. So 3 times 4 plus 5, or 17. And it's not labeled, oh, it is labeled with units, so we're going to do 17 centimeters. Next, this has a triangle that has an area of 24 square meters, and the base is 2 meters longer than the height. What is the length of the base? That means we're going to use our area formula, which is base times height divided by 2, or half base times height. And we're going to plug in what we have. So we have the area is 24. We have that the base is 2 meters longer than the height. So if we do the height as h, the base would be h plus 2. So h times h plus 2 over 2 equals 24. So now we need to find the base, which we need to solve for h to find that first. So we multiply by 2 to cancel out this 2 first. That gives us 48 equals h plus 2 times h. And we need to distribute the h, so that gives us 48 equals h squared plus 2h. We actually cannot combine the h squared and the 2h. So the reason why this is actually on here, and you will not have to do any kind of factoring, is that you need to factor in order to get h. So how you would factor this is you'd bring the 48 over to be with the h squared plus 2h, and you'd get 0 equals h squared plus 2h plus 48, or sorry, minus 48. And then you're trying to figure out what two numbers would multiply together to get negative 48 and add together to get 2, positive 2. So I'm going to say 8 and 6. If we do a negative 6 plus 8, that would still give us negative 48 and positive 2. So we're going to set it up as h plus 6 and h minus, nope, h plus 8 and h minus 6. So that way, if we use the FOIL pattern from last year, if you remember, then we would multiply it all out and it would get us back to where we started. But what we're doing here to find h is we need to get a number that's obviously not negative, because we don't have distances of bases be negative. So we're not going to use the h plus 8 option. We're going to use and solve the h minus 6 option. And we put that equal to 0. We add 6, so h would be 6. Now, that's h. The base was 6 plus 2, or h plus 2. So this would actually give you 8 as the base. The next one, the area of a circle is equal to the area of a square measuring 5 centimeters on each side. Find the radius of the circle. So if you're using the area of a square formula, that's length times width. The area of a circle formula is pi r squared. So let's see what we have. The area of a circle is equal to the area of a square measuring 5 centimeters on each side. Well, that's going to be, the area of a square is 25. 5 times 5. So then that means if the area has to be equal to that area, we're going to put 25 equal to pi r squared. and then we divide by pi, and we get r squared equals 25 divided by pi, which is about 7.96, and then we have to take the square root to get just r. So the square root of 7.96 is about 2.8 or 2.82. And that gives us our radius. The next one we're going to use for the next three problems, this diagram, or this coordinate plane. So the first, it says find the distance between L and M, so we need to get their coordinates. So if we look here, that's 1, 2, 3, 4, 5. So -5, -1 is L. And then M is 1, 2, 1, 2, 3. So 2, 3. Now we're going to find the distance here, so we need the distance formula. That's subtracting the x's squared plus subtracting the y's squared. So we get -7 squared, or 49, plus -4 squared, or 16, and that gives us the square root of 64, which actually gives us a number of 8. So 8 is our answer. Oh, I'm sorry, that's not 64, that's 65. So it's the square root of 65, and we can actually just leave that as the square root of 65. Okay, so we don't need to write it as a decimal. The next one, we're finding the coordinates of the midpoint, so back to our M and N. M was 2, 3, and N now is 1, 2, 3, 4, 5, -3. So 2, 3, and 5, -3. Midpoint formula is the x's added up, divided by 2, comma, the y's added up, divided by 2. So we get 2 plus 5 over 2, or 7 over 2. And 3 plus -3 is 0. 0 over 2 is 0. So we get 7 over 2, comma, 0, or 3.5, comma, 0. And that's our midpoint. And then the coordinates of a point Q, if P is the midpoint of NQ, we need to find N is going to be 5, -3. Okay. 5, -3 for N, and then P is 3, -2. And we need to find Q. So if P is the midpoint, we're going to use the midpoint formula and set this up. Oops. So we're going to do 5 plus x over 2, and that's going to be equal to our midpoint coordinate, which is 3. We're going to solve that, and then we're going to do the y's. So -3 plus y over 2 equals -2, because that's the coordinate for our y point in our midpoint. And we're going to solve both of these. So we always multiply by 2 first, both sides. That gives us 5 plus x equals 6, and then we just subtract the 5. So x would be 1. Here we would multiply by 2 first, always multiply by 2. Then we get -3 plus y equals -4. Add the 3. So y would be -1. So our point then would be 1, -1, the other end point. Now we have the vertices of a triangle, and those are located at these 3 points. We need to find the perimeter, so we're going to probably be using the distance formula. If I were to do just a general graph here to get an idea, I have P is 0, 6. And then 8, 12 is Q. I think I'm going to change my scale here a little bit so that I'm able to fit this and do this by 2s. So that means this is P. And then this would be Q. And then 3, -3 would be R. And that's R. Okay, so just to get a better idea, to see if we can do any counting, but I don't think we do. I think we're going to have to find the distance formula separately 3 times. So if we have the distance formula here, we're going to do the distance formula for PQ. That's 0, 6, and 8, 12. So using those 2 points, that gives us 0 plus 8, or 0 minus 8 squared plus 6 minus 12 squared. That gives me -8 squared, or 64, -6 squared, or 36, and that gives me 100. So the square root of 100 is 10. So that's 10. And then we're going to keep going and do the next 2 numbers using the distance formula. So that's going to give us, P was 0, 6, and R is 3, -3. We'll do that distance now. So 0 minus 3 squared plus 6 minus -3 squared. And we're going to do the square root, so that gives us 9, and 9 squared is 81, or the square root of 90. So I'm going to label that as the square root of 90. And then the last distance is going to be 3, -3, and 8, 12. So 8 minus 3 squared plus 12 minus -3 squared gives us 25 plus 275, or the square root of, not 275, 225, I believe, because 15 squared times 15 squared is 225. Sorry about that. So 225 plus 25 is going to give us 250. So the square root of 250 is for QR. So if we're going to do the distance or the perimeter of these, you can just keep it in terms of square roots. So you could literally just write 10 plus the square root of 90 plus the square root of 250 as your answer. And that's going to be units, because we don't know how many units this is or what the units are. Next one. We're going to find the value of x if RS bisects AB and RS is 36. So RS, the total here, is going to be 36, it's saying. And if something bisects something, that means that it makes it equal. So if it's bisecting AB, that means these two are equal. But we need to find y first to be able to solve the AB. And we're going to ultimately need to find x. So we need to find y first. We can do RS by doing 2y minus 6 plus 18 to be a total of 36, which it showed me. So 2y minus 6 equals 18, because subtracting 36 minus 18. And then you add 6, so 2y equals 24, and then y would be 12. And once we have y as 12, we can solve for x by doing these a and b equal to each other. So 25 minus 3x equals, we plug in 12 for y, that gives me 24 minus 5, and that's going to give me 19, so equals 19, and now we can solve for x. So minus 25, I get -6 equals -3x, and so I divide by -3, and I get +2. So my answer is +2. Next one, we're supposed to measure with a protractor. So you're going to line up the protractor exactly in the middle with point B. And that's going to give you an obtuse angle, which we can clearly see, and since the left side is what we're looking at, and we know it's obtuse already, we're going to look in the inside scale of the protractor. So you get about 135 as your measurement, so 135 degrees, and we could clearly see before measuring that it's obtuse, so that could also help us to figure out what the actual measurement is, because we're not going to do a lower number like 45 if we already know that it's obtuse. All right, this one is, we're using the figure. It says RC and RD are opposite rays, like this, and RQ bisects WRV. So this right here bisects this. Okay, so with all that information, that means WRQ and WQV are equal. And if we have opposite rays, that means that it's making a perpendicular lines, or I'm sorry, a straight angle, which means that PR has to be perpendicular to CD, and that's going to give us that 13x plus 12 has to equal 90. Oh, okay, this is all they're saying in the beginning. Whoops, I was getting ahead of myself. Okay, so this is what they've told us so far. If we go to the next problem, this is what it's asking us to find. It says find the value of y if WRQ is 48. So WRQ is here, 48. And then VRQ is going to be 7y plus 6. That's going to be here. So to find y, we would just put them equal to each other. 48 equals 7y plus 6. So y equals 6, because you get 7y equals 42, and then we divide by 7. So y is 6. Next one, find the value of x so that CR is perpendicular to PR. That one is what I was talking about to begin with. So 13 plus x plus 12, that makes that equal to 90, since these are perpendicular. So that's how we can solve for x for that one. So we get 78 equals 13x, and that's going to give us also 6, I believe. Yeah, so x would be 6. And then this one is going to be used for the next 4 problems. So I'm going to keep going back and forth. If it's asking to find the value of x, we need to think of what x is. So x is actually across from the vertical angle 58. So to solve for x, we would have to do 9x minus 5 equal 58. And then we would add 5 to get 9x equals 63, which gives us x is 7. And then finding angles 1 and 2, that's going to get, well, angle 1 is vertical with across from it these two, but we don't know y yet. We can find y by doing 7y plus 27 equals 90. That'll do the next one. So we can kind of jump around here. So that also gives us 63 equals 7. So y would be 9. And then if we have 9 here, and this is 7 here, we have 63 minus, so this is 58. And this would be 63 plus, this would be 90. Obviously, it's labeled like that. So 58 plus 90 plus angle 2, all that has to equal the straight angle, or 180. So 58 plus 90 plus x has to equal 180, and you could solve that way. So 148 plus x equals 180, and you'd solve by subtracting 180 minus 148. So that gives us 32. So 32 is going to be angle 2. And then angle 1 is going to be 90 plus 32, which is going to give us 122, because it's vertical from these two like I showed you. Okay, and the next one, we need to name the polygon RSTUV by its side. So there's 5 sides, that means it's a pentagon. It does not cave in, so it's convex. And notice all the angles are labeled as the same and all the sides are labeled as the same, so that would be regular, not regular. All right, find the length of each side of the polygon. This one, notice that all the sides are the same, so we would just put it equal to each other and solve for x that way. So you get 4x equals 24, or x equals 6. And then the last one, or 2 more. 2 angles, A and B, form a linear pair. Angle B is an obtuse angle. What type of angle is angle A? Well, it has to be acute if it forms a linear pair, because the two have to add up to 180, so it is acute. And then the last one, and the last problem is a word problem, so I'll read it. It says, Nadia wants to fill her rectangular fish tank with water. The fish tank measures 2 feet wide, 1 feet long, and 1.5 feet high. The water level in her fish tank needs to be 0.25 feet. So she uses a bucket that holds 1.25 cubic feet of water. We need to figure out how many buckets of water she needs to fill the tank. So we need to find the volume of the rectangular prism, which is what the fish tank is. So the volume is just length times width times height. That's 2 times 1 times 1.5, which is 3 feet. So if the water level needs to be 0.25 feet, and she uses a bucket that holds 1.25 cubic feet of water, how many buckets of water does Nadia need to fill the fish tank? So if you have 3 feet in your bucket, and it needs to be, or 3 feet in your fish tank, and the fish tank level needs to be 0.25 feet, and the bucket holds 1.25 cubic feet, then that means you're going to have to do 3 divided by 0.25, which gives you 12, and then 12, whoops, that's not right. So if you think of 3 feet as being the volume, just focus on the fact that 1.5 feet is the height. Okay, so if you think of the water level being up the side to be 0.25 feet, that's going to mean that you have 1 foot left to have to fill. So if you have a bucket that holds 1.25 feet, that means you're going to need 2 buckets to fill the tank to be able to reach the total water level that you need. And that concludes the Chapter 1 test review.